recording. All right, so we're in the last section for Monday, February 18. Most classes had like 17 to 19 project postings for Sprint 1. Each class has like 26 students, which means quite a few of you didn't post. So if you had problems, that's okay. Come into lab time. This is why I get that first project out like right away. I know some of you aren't used to a style of class like this, but it's good to get into a standard sprint style. And this class is just all coding and interaction design. So just that's why I wanted you to do your WebGL build test quickly in week 2, because a lot of you had issues. I helped you as much as I could over the weekend. But come in and whatever. It's just going to be a little late penalty, and then moving on, get your deliverables posted up. So remember, lab time is Monday, Wednesday, Thursday. So come in if you got stuck. Also, as you get new ideas and you want to experiment with new things, I'm moving along with this like paint program, and I'm just going to add more features and introducing new concepts through this paint program. But if you have new ideas, come in and talk. Let's make sure it's like scoped appropriately. It makes sense within this class, this knowledge that you're learning, and like for the amount of time you have for the semester, it makes sense. And that's also what I want. That's the point of this class, is to kind of break free of this educational style you're used to, which is a lot of memorization, and just repeat what I do. Because there's 2 main points to this class, which is like more experience with coding, learn how to code, but learn how to code your own ideas. And then this idea of interaction design, like, yeah, that's great. You're more self-sufficient as a programmer, but what you're making, is it pleasant for the user? Does it make sense for them? This idea that you're developing for someone else, not you, so they might not have such an intuitive grasp of how your program works because they're not the ones who made it. So how to have clean, functioning user interfaces, easy input, directions where it's needed, at least some thought into style, color, text that you're using, what have you. So anyway, I'm going to continue on, and I'm developing my app further, and I'm going to use it as a demo, and I'm going to get it up into, now we're moving on into Sprint 2, which is due at the end of spring break, which is March 24 at midnight. So you've got like quite a few bit of time. You're going to want to start, you're going to follow along with me. You're going to be working on watching these videos. You're going to be programming, learning concepts, and then working on your own project. So hopefully I got you into a style, into a rhythm to just start working now each week. And if those of you who got your foot caught in a trap over the weekend, that's why you don't do these projects all last minute. So I'm not going to be posting up like in the first sprint, like, oh, make sure you do this part of your project, and make sure you do that part, and make sure you do this part, and then you should be a clean delivery and no issues. Now you see that you can't do all this stuff last minute. So I'm going to be moving forward. The class style, my core of teaching is still the same, interaction design and programming, but now I start like you guys were coming to me with all these interesting new features that you wanted last sprint. Some of them I included into my project. Some of them were a little bit too much, and now I have some new stuff to work on during the week. So I'm more loose as I move for the rest of the semester. As long as I'm doing new features, I'm exposing you to new coding structures, new ways of thinking as you're programming. This is good, and then I kind of just move on the project ideas that you guys have, because it's going to be more interesting for you anyway. So just know that we still do a drop like every month or so, and then you have your final exam. But the class structure is going to be, or I guess the topics will be a little bit looser. So just make sure you follow along with the videos, you do the program, you actually understand what's happening. and then you just spend some time each week working on your project so that you just do your drop and you can move on to next. You're supposed to be breaking your workout over week. Time management, these are skills that you have to develop for leaving college. So similar to Sprint 1, where I put up a little sample project. So I have my project description. From my project description, which is kind of like my overarching idea of what it is I'm trying to build and what the point of it is, what's the benefit to the user, what aspects do I have to consider as I'm designing and developing it. That then leads me to be a little bit more modular, to break down these user experiences into user flows, which are discrete experiences that the user has access to, features they have access to. So, for example, my Sprint 1, I had a painting workflow, which was my primary one, and then I had these change primitive, change colors. Last week, you noticed I did a few more features, like changing the size and deleting everything, clearing everything out, and being able to turn on and off time destroy. So these actually going into Sprint 2. These are new features, but students were already like hitting upon these situations. They wanted to know about them. I did them. There was a lot of content last week. I'm going to go over it again this week. And I've already, these are basically like 3 or 4 new features, which I've already developed for my Sprint 2. Your Sprint 2, you're going to want, I think I'm going to hone in on around 5 features. I haven't set the number yet, but I will give you clear directions at the end of the week of how many features you need to develop. But at the end of the day, it's the same thing. You're going to have a project description. You're going to describe all these features, and then you're going to diagram them out with Draw.io. You're going to put your diagrams in here. You're going to put a link to your project. And I don't know I actually figured out how to embed the itch.io. It's just like it shows you the line of code. You copy it, and there's like a little like insert code in your Moodle posting, and then it plays right in your Moodle posting. Super cool. It was working. I don't know why it's not working now. Maybe it's something with NGIT internet blocking it or whatever. Let me figure it out later. But I would love to get your posts like this, where it's like, this is what I'm trying to make. Here's some more modular descriptions that lead more into my code, and here's the actual implementation, the actual deliverable I came up with. So in this case, you're still going to need a link just in case this happens, but I'm going to show you how to embed your project too. So some of you will continue following along with me, modifying, growing your painting program. Some of you might choose to just do something else. The core of it is like 5 features that you have thought about the user. You thought about how you're going to have to deal with user input, keyboard, mouse. You thought about what type of user interface elements you're going to need. You've diagrammed out your flows, and you've actually gone ahead and coded it. The rest of the class, I'm going to be talking more about like graphics and animation and physics and all these cool new areas. And it's going to be hard to just stick exactly with what I do. You're actually going to probably spend more effort trying to deliver a project that's exactly to spec what I'm doing than if you just had fun with it and morphed off it. So, for example, this week, I'm going to go over this new feature which lets my paint strokes kind of scale up if the user is drawing really fastly. So it kind of scales the objects to the distance between the spawn points so that it kind of fills it more like a stroke. All right, I'll cancel that back out and make it look like it did last week. But this is where I'm at right now. And you can do that with whatever object you put into it. It's just scaling it, because if you move the stroke really fastly, there's going to be big gaping holes in your stroke. So obviously this code is going to be on the video, and you can just write it out. But all you got to do is mess around with these numbers, and all of a sudden you have a drastically different paint stroke than I do. So even if you're not at the point of coming up with some interesting independent ideas you would like to pursue, even within the context of Paint program, which most of you are already deviating off of me, then at least you can modify the math that's going on very easily. Even expose this math. I've showed you how to make them variables and expose them to yourself in the inspector, or expose them to the user through a user interface element. And you're already iterating off of me. So the ultimate goal here is to become better at creative problem solving. That makes for a much better programmer, or whatever job role you really take. It's creative problem solving is a huge part of it. You can even come up with ideas like, oh, how do I do this, and do a clean Google search, like you're worded it appropriately. You'll find the code. All of this has been done already, but even that is a skill set for a coder. Most of the time, coders just know how to word their questions correctly. They go on like Stack Overflow or the Unity forums, and somebody has already solved that feature, that aspect, that math condition you're trying to find, and that's actually a real skill set for a professional programmer. You're not doing everything from scratch, and that I don't mind. You need to understand what the code is doing. If you're just copying and pasting stuff, you're not learning anything. Once you start, you're going to come upon so many tangent areas that you just don't get yet, because your experience is not there. But as you come up on roadblocks, you're like, wait a minute, I kind of want to try this. What if the user presses left and right at the same time and I want to do this? And you figure it out, and you might not know what it's doing, but at least you found an answer that works, and you can kind of work your way through it a little bit. And over time, you'll learn what it's doing. Now you've grown as a coder, and then you're ready for bigger challenges. Like, this is a natural growth progression in this skill set, and this is what you should be trying to demonstrate in this class and grow. All right, so before I get into the code, that's the posting. You should know what to expect for delivery. So here we are. You should have dropped. If not, come in. Let's figure out the issues. Let's get it worked out. I am going to be going over my code and showing where I'm getting to. And then later in the week, I'll finish my demo, get it up, and but just know you should be aiming for something with 5 feature points. And here is the drop, the 34th, right at the end of spring break. And then we go on. We'll have another drop and another drop in our final exam. And then that's class. For this week, besides myself, I actually really like this tutorial. This guy's really good. Cat-like coding. This is his first basics tutorial. It's building a clock. So I'm going to do this. I'm going to go through this with the online lectures for this week. One of the reasons is he starts from scratch. So he's like, oh, let's create a C# script. What is that? And what's a variable? And what's a game object? But he approaches it differently than I do. And he's a great instructor. And now's the time where I kind of went through the fundamentals with you. And I'm trying to get you, I'm going to be going through new stuff like animation and physics, but I'm trying to get you to push out on your own. I think it's a good time to just go back, go through the basics again, but from a different angle. Because I did see some stuff last week and over the weekend where stuff were like people were using prefabs, or they're using script components correctly in some aspect, but incorrectly in others. So I was like, some of you are starting to get it. You just need to go through the initial steps again, and I think a lot more stuff will click. So anyway, it's long, but from my perspective, it's really cool. You're making this clock that, let me turn it on, actually reads in the system time on your computer and animates the clock. So all the rotation aspects of the hour, minute, and second hand are actually reading in real-time information and updating or animating. And then if I click here, notice how the second hand is kind of doing that discrete movement per second. And if I click on continuous, it's got that smooth transition through the second to the next. So the other thing I like about this is we're building like a representative of a real world object. And you're thinking through the steps like, oh, okay, each hour segment, if we think of a circle at 360 degrees, we have 12 hours. So let's see, that's 360 divided by 12. That's 30 degrees per section. And so you start to think through how to build this object and then how to update or animate as real-time information is coming in. So, and I like how it's an analog to a physical object. I think it grounds everything for you. So that's why we're going to use this object. We're going to build it. It's going to be like your introduction to animation with code. And it allows you to have somebody else explain all these programming and Unity basics to you. And he's good. So, and also at the end of this, you have the Unity package of the whole thing, which you shouldn't need. You should be able to build this by hand, but just in case. And a PDF. Like the whole thing is a nice format. You can download it. It's like 30 pages. The second tutorial is this animated node graph based off sine waves. So the position of these cubes are updated just off a basic sine wave, and the color on the shader is changing based not only on its height, its y position, but on its x position. And you can feed in different math functions as you care to. So I think this is really cool. This I think will be next sprint. But know that these projects encapsulate a lot of the next areas of the class. And then maybe this gives you some inspiration, some ideas for other things you want to create. For me, what I think I'm going to get to is I think I'm going to have the clock time read into my light source. And so we can change the day and night cycle based on the actual time. And when that happens, I'm going to change my paint strokes. So I think when it's nighttime and it's dark, I'm going to have like my paint strokes glow, emit light, or maybe have a particle system sparkling or something. Something introduce you to some new concept with that. And then obviously, since this class is always at 2, 3 in the afternoon, I'm going to have a little toggle between AM and PM so that we can quickly jump that 3 o'clock. I can switch between AM and PM and see what it's like in a day and night situation. So I don't know if I think I have enough features with modifying the paint stroke and all this destroy stuff for sprint 2, but we'll see. This might be sprint 3 or, we have enough content. We can always make more, but just know that these are some of the things coming down the pike. So I'll turn the clock off and the graph, and just know that I put the link up. In my videos, I'll be going through the tutorial, but you just spend your time. Now it's this whole massive web page you can just scroll through. I like, if you want additional information, you click on these gray boxes. So if you want to learn more about using statements or what have you, you can open up and read more. Why are public fields bad? I kind of talk about this. I know he's talking about it. Yeah, so this is my paint app as is. I did a few more features that were beyond sprint 1. It's just people needed it. I put it in the videos, but just know that the size and the clear and the time destroy were not part of your sprint 1 obligations. And yes, so somebody brought up if you want to use the lab computers, if you want your Unity on your laptop to be the same as the lab computers, download Unity packages. It's a pretty easy process. If you're like in the newest Unity, 2018.3.6 or whatever, just open up your project view, right click and export package. This is basically like a zip file. They call it a Unity package. It just kind of takes all your assets, your external assets, which are script files, shader files, materials, any prefabs you made, Unity scenes, zips them all up, and you can take them somewhere else. So all the information you need, it's all right here. Click export, it'll create a little file. I think I already have one on my desktop. Yeah, like this test here. If I drag it in, it says, okay, this is what I found from this package. It's going to overwrite. It has these files. We're going to overwrite this information. These are new, what have you. Do you want to import it in? So this is an import-export process. So export out all your crap. Uninstall Unity. And then if you go to Get Unity, this is what it looks like, right? This downloads the most recent version. Don't want to do that. Come on down. Older versions. What's on the lab computers is this one. I'm running this one. So actually what I'm doing is a lot of people had issues this weekend and they were running the newest version, 3.6 or whatever. I ended up having to export out your stuff just as I showed you, and I brought it into a new project because I can't open up Unity 2018.3 in my .2. It's too much of a difference. It's too big of a difference of their code base. So I'm here. The lab is here. Think about just sticking with at least the .2s. You'll get through the semester much easier with using lab computers, and if I have to open your stuff. With all that said, I'm going to go into my app and explain the new elements, size, the clear button, time destroy. This, I'm just starting to build this out. This is going to be this is called a scroll bar. It's good for like discrete values. So as opposed to a slider where it's like a continuous range of decimal values, this is going to be for integers. I'm going to use this to specify different destroy times. So if you want your objects to destroy after 1, 2, 3, 4, 5 seconds, I'm going to add that feature. And I have some little directions now. Right click to paint, left click to erase. All right, so I'm going to cancel this out. I showed you what the new paint stroke looks like. I'm going to go back to where it was. I think I accidentally, in the last class, I just deleted something. So let me just put that back. Yep, this should all be good. This I got to pop back to 1. And yep, this is where we were. Awesome. And I think my sliders, I modify these sliders in class. I think I'm going to have to, yeah, I got to go back. And then I'll show you why I'm modifying these. All right. So while I was back on this scroll bar, this allows me to talk about the anchor point, why it's important. So by default, you have this anchor put at the center, right? So remember I told you your game view, first off, create a custom aspect ratio, 960 by 600. The reason for that is what your WebGL build aspect's going to be at. So to make sure your UI elements, everything looks correct, and it looks the same as when you build it, set your game view to this proportion so that you can make sure that no matter what the size is on your client's user's computer, that your UI elements kind of stick where they're supposed to. Notice as I'm moving, the scroll bar doesn't stick where it's supposed to. So position it. Let's say I want it to be part of this cluster of UI elements here. So once I position it correctly, scale it, label it, whatever you need to do, the anchor is really important. So the anchor is like, where on the screen should this thing clamp to whenever we're dealing with a windowed situation, the window's scaling up and down. So at first we can see we're at the left side of the screen. So okay, let's clamp it to the left. That makes sense. So as I mess around with all the actual sizes that this could be viewed on, notice that at least it's staying on the left side, but it's not moving with its sister elements, with its corresponding elements, kind of cutting through them a little bit. Notice that if I keep going, everything just looks like crap. Like at this situation, it just doesn't even make sense to have a UI. So this will never happen. Most likely is we're testing for the most frequent use cases, the most frequent scale screen sizes, which might be something like this and maybe, something like that. So as long as it looks good in this kind of range, we're good to go. So I see that this scroll bar does have a little bit of issues. So I should move it with the rest of its related content, which happens to be down in the corner, left bottom. So I'm going to anchor it left bottom. So as I move it, notice it looks good. It sticks on the top of its group, and eventually they do cut through. I'm not really worried about that. So notice I had to go through all these elements and set their anchor points. So eventually what you can do is you can create, notice all these elements are sitting under the canvas, kind of similar to the hierarchy that we're in, how we kind of have all these objects sitting in there. Sometimes we group them to make sense, to make it cleaner, and also to move something, we just have to move the parent object and everything else comes along for the ride. So you could consider creating like a parent object and putting all these, everything that's meant to be clamped like in the bottom left, you could put them under like an empty game object in your canvas and just make that game object link or anchor to bottom left. Then you don't have to go through all of them. It's just saving you some work time. And again, we kind of covered what this is, these parent-child relationships. We did that with these prefabs and clustered game objects together. Then you only have to move the parent or scale the parent, rotate, and they all kind of come along for the ride. So in this hierarchy mode, these parent-child relationships are very similar to like tree structures if you studied them in computer science, where trees might have leaves or nodes, or stems or whatever their names are. Here we're calling it parent-children, and they can get really complicated, a hierarchy structure. Here we just have like a parent, and we're going to put everything underneath the parent. We're also going to make use of that feature when we do the destroy button. Okay, so I think I covered everything leading up to going through the script. So notice that the script name is different now. Script 2. The file name is different. If the file name is different, the class name needs to be different too. They need to match. So I had some students asking me, like, I had like all the same functionality last week in the script, but the script name was different. I called it script 1 as opposed to like screen to world point or whatever. And they were asking me if that changes the functionality or what have you. No, it's every file name can have a distinct name as long as the class within it has the same name. And since I'm moving into Sprint 2, I just duplicated my Sprint 1 script and just renamed it. And I went in and changed the class name too, or else you're going to get a compile error. And now I have all this code, this great stuff that you're aware of, and I can start building more features for it. So these should all be familiar. All these floats and ints, the mouse position text, all this was at the end of Sprint 1. Click position, and I'm going to go through that. And this is new. This is this new feature that I'll cover at the end of class, how I'm keeping track of my last spawn point so that I know how to morph my current paint object so that I don't have all these big gaps in a line if the user is moving the mouse really fast. So in our update loop, first off, we're checking for a left click. So if there's a left click or a left hold, get mouse button down or get mouse button, and it's reading in a 0. So We have an array of information. Arrays are lists where the indices start at 0. And for mice or touch event points, 0 is left click, 1 is right click, 2 is middle click. And for touch events on touch screen, that's how many fingers are actually active during a touch event. So in this case, I'm using one of the 3 input scripts that I went over in week 2. So I went over screen point to world, this one, screen point to array, and then I went over that like creating this mathematically infinite plane and using this raycast event on the plane. This case I'm using the second one. So I'm using it because in this situation I want to click on objects that I've created and destroy them. So I want to be able to read in where the mouse input is. I want to be able to shoot a ray out into the world from that position with the direction that the camera is pointing. And if that ray, that vector, hits something, hits a collider, I want to know about it. Because the only thing that can be existing in my world at this point that has a collider are the paint objects. Either the Unity primitives I'm spawning or the prefabs that I showed you how to create. All of them have colliders, physics colliders on them. So we use this function that's coming from the camera. It's going to read in the mouse position. We're creating this data structure called array, very similar to a vector. And then we create another data structure called this raycast hit. This is going to be the information given back to us if we do get a hit, if we do hit a collider. Now we have to do a check. We actually have to shoot out that raycast. So physics.raycast, we're going to initiate a casting, a shooting of a ray. And it says what ray are we shooting out and what's the information do we create and send back to you if we do hit something. So this is an if statement because it only returns true if it hits a collider. Else, which we could put an else statement if we don't hit anything, if we do not hit something, do something else. But I have no need for that. I'm just checking if we do hit a collider. If we do hit a collider, I want to destroy it. So this is my functionality of left clicking and paint and erasing objects. So remember the destroy method only works on game objects. So we have to get the game object from this hit information. This data structure called hit has a whole bunch of information like the location where the hit happened, what is this other collider we're hitting. In this case, it's a physics collider. The physics collider is aware of the transform of what we're hitting. So the convention anyway is take this hit data structure, go find the transform of this object that we hit. Remember the transform on let me click on this sphere here. This transform is a component on a game object which has other components. But if we know that it has a transform, we can go up. That transform is aware of its game object, the entire thing, not just a component. We're deleting the whole thing. You can delete components as well. In this case, if we click on something that has a collider, delete the whole thing, not the transform, not the collider, just get rid of that whole paint object. So we can do other things with this information. I'm using it as a way for the user to have an erase feature. But you can also have other features. Say you want to change a color on an object. Okay, the user would somehow go into the user interface, select a color, say click on like, okay, whatever I'm going to click on, change the color, and then click on something. And then if it reads in a collider, instead of destroying it, you're setting its material to another color. What color? Well, whatever the color that they set in the user interface element. So you can use this to say modify, scale it, change the scale, change the whole object, right? Say maybe we're painting spheres, but the user's like, no, I want to change that to a cube. Well, we can do that with this type of feature. I'm just using it as an erase feature. But the broader sense of it, the more abstract situation, is that I'm really shooting out a right cast from where the mouse position is into the world and seeing if I hit something. You can do whatever you want with that, right? So this check we're going to get into later. And this has to do with the new feature. Just note that this is get mouse button up. This is only true when the user releases their finger, in this case, from the right mouse button. I'll get into why I need to do that. This you're familiar with. This is get mouse button down or get mouse button. If they're clicking or holding down the right mouse button is true, we go in here. In this case, I'm using another way to read in user input. It was the first method from week 2, screen to world point. So this reads in the mouse position, X and Y on the screen, and then we are allowed to set the distance. So for me, this is useful for painting because I get to set the distance and I can even open it up. Remember, I was kind of had that distance change value where it's kind of fluctuating the paint stroke back and forth. Maybe later on I care to do that. But for right now, I can open up to the user, hey, what distance do you want to paint at? And so this method is most useful for me to do the create or the paint method. So now we're using two different, input styles. Once we found out that the user is clicking, we found out where they're clicking and how deep are the distance into the world that we wish to do. I'm going to figure out what I should be painting, what I should be creating. Real quickly, I saw in some of the scripts, some of the events seemed out of order. Like you were destroying something, then you were creating something, then you were modifying something. Or you were modifying something and then creating something. So it doesn't really make sense because you first need to create something. Then you can modify what has then been created. Then you can destroy what has been created. So think about all these lines of code are executed in order of sequence. And so you must create something before you can destroy something. And somebody was saying, oh, well, that's really destroying a previous object. And then we're creating again. I'm like, what? Just so you know that the way it's being read is it looks like you're destroying your object and then you're creating it. So and later on, I'm going to be getting into how to keep information from the last thing, the last time we interact, the last time we create something, to make use of it this time. So you should, if this is a situation where you need to manipulate previous objects, you should be saving references to them and making that reference very specific, saying last object equals this. Okay, last object, destroy, and then create new object. Now it's very apparent in your code to you and me and anyone else that you're actually destroying something else and then creating this new thing, or manipulating something else. Then you're creating something new. But in this case, the first thing I do, once I realize it was user input, is I'm going to create something. So what are we creating? Well, I'm giving this option to the user. By default, this shape is an int. By default, I'm setting it equal to 0. In the 0 case, we're just creating spheres. That's my default painting tool. So this allowed me to introduce a new type of decision statement. This is a switch statement. You can do this code with an if else, several ifs. Sometimes it gets a little messy, and if your if statements are getting really complex, especially if you're nesting ifs within ifs and all this kind of stuff, you might want to look at switch statements or other ways to make these decision points in your code. So the way a switch statement works is it needs to read in some type of variable, usually it's an int, to make a decision on, and then we look through all these cases. Is this case true? Is shape equal to 0? If so, do this code. Is shape equal to 1? If so, do this code. Usually we just execute one case, and then notice after each case there's a break, meaning we leave this block of code. So if these breaks were not here, if shape did equal 0, we would go through and execute this code, and then we would go through and execute all code, and then leave that block of code. Since it's a decision point that does separate pieces of code based on what this value is, we don't want that. So just know that usually each case has a distinct number. It uses a colon. You do whatever code, series of lines of code, and then you break out and you leave. Breaks and returns. You can use these in method calls too. Like if a certain situation, you're checking a certain situation, it happens, you do something and you break. You leave that whole method. You don't keep going. You leave that method altogether. All right, and then returns we'll get into later on. That's all the way like it doesn't have to be at the end of a method, because if certain situations you're testing for, you might go into an if statement. If certain things happen, you're going to return a value. Either if it's a void, an int, a float, whatever that method returns, and you're done. You return something, you're out, even though you're like halfway through the code. But one thing I didn't cover last week was default. Usually switch statements will end with a default. So if none of the previous cases are true, do default. So you fall back on what is your plan B if nothing's true. You don't have to have this. If none of the cases are true, we just go through the whole switch statement. Nothing happened. And just note that a default statement has that breakout as well. Although technically we're at the end of the switch statement. You don't need it. But just be by convention, just place it in there. So these numbers were tripping up some of you. These numbers are arbitrary. I assigned them when I made the user interface. They don't always have to be these numbers. There can be more or less cases. They can have different numbers depending on what your little system is you're making. In my case, these numbers are coming directly from my drop down here. So the whole thing that's setting this off, okay, so let's say the user doesn't use the user interface. I have shapes set to 0 specifically. Just draw spheres. Just draw something. I want spheres. If the user does use the user interface, I gave them the option here. And you can make more, but my dropdown, my list has 3 things. You can have 4, 5, 6. They could be your own prefabs that you want. The point is that you have to give a name to them. This name means nothing. These are just shown to the user when you click play. This is just so that the user has some type of human legible text to understand what these options mean. But these options behind the scenes are really just an enumeration. Or what enumeration is just a list that has a label or a text associated with a number. So just like arrays or lists, they start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a list, a customized length that you're creating based on the number of options you want in your dropdown. We always start from 0. So I say, hey user, do you want to spawn a sphere, a cube, or a cylinder? What this really means behind the scenes is, do you want 0, 1, or 2? And if I scrub down here, on value changed, it's going to send out integers. So int 32, that's just the structure, 32 bits to the size of it. Just ignore it. Just say that this is an integer. Okay? This int will be passed somewhere. So when this dropdown is changed, for example, user switches that to a cube, this int for a cube, which means 1, it's the second choice, which we list as 1, 0, 1, 2. It's going to be passed to this method, which I made the connection to. I made this method and I made the connection to. It's all customized by whatever your needs are. What happens when that change shape is called? Well, it passes in this integer that's coming from our drop-down list, and we're setting our private int to that. Remember, all our integers are variables are our responsibility. So we use method calls, public method calls, if anyone else wishes to change our variables. We can do checks and safety checks and what have you in these method calls. But right now I'm just directly setting that integer shape, which is my int, which is making my decision point on my switch statement. which is why it's case 0, 1, 2. And I'm saying, hey, if it's case 0, create a sphere. If it's case 1, do a cube. If it's case 2, do a cylinder. The only reason for that is because I made the drop down in that order and gave labels on it that the user is recognizing as the paint stroke, right? So you can switch this up. I can switch the order here. I can add more. Just know that if you switch it up, it needs to correspond to that same code you're executing. And these numbers are just these enumerations which are coming from this dropdown, which passes out integers when you change it based on this enumeration, this list that has labels associated with it. All right, so that's the switch statement. All good. So this, we're just changing the scale of the object. So this was somebody wanted to give the influence of the size to the user, but she was having issues because her user interface was changing integers, and though she was using integers for her size parameter, and although that the size was changing and she was happy with that, it was doing this discrete change of size. It was going from like small to medium to big, nothing in between, no continuous change. I was like, oh well, all right. What you really want is a float, because that allows you to connect it to a slider to get a nice continuous change, right? So that's where we just set up a size slider, very similar to the color sliders. And before we set the numbers up for that, you need to play with this size by yourself. So since I created this code, I exposed this number out to the inspector, or I played with this number a lot, and I found out what makes sense to me. Well, for me, a half unit, scale it by half, makes sense as a default, only because it makes a paint stroke of this size, which feels right. That's a good starting point. Great. So I know that a half unit is a good starting point. Now I got to figure out my min and max. Well, playing with my scripts and messing around with those numbers should give me a feel for what this min and max should be that I should give the user. So just know that scales of 0, like flatten the object out, that's no good. It doesn't look good. Scales of negative are bad. You don't, based on what you're building for, you don't know how the platform is going to correspond to negative scale. It might like render the whole thing black, or you might get this pink. Don't do negative scaling. So, all right, I know that some minimum value, 0.1, makes sense. I know that the default should be like half a unit. And then you can, what's the max? I don't know, 1, 2, whatever you feel is correct. So I made the slider. I set its min-max default, connected it to my float, and I just multiplied my x. My randomization, my x, y, and z, I just multiplied it by that float. And then that allowed me to get the size. So that's great. Oh no, that's too big. Scale back a little bit. Now you can play around with what the size of your paint stroke you want. And if it's too big, you know, then you can always clamp down your slider. What's important to note with your user interface and your default values is that you need to set them up the same. So for example, I found that a 0.5 is a nice number to default to for the size of my paint stroke. So I set my script up to that. I put that 0.5 in there, and that's what I'm running. If I never touch a user interface, this is what the paint stroke is doing. Now, the user interface is defaulting to that same value, but they're not actually connected yet because the user hasn't messed around with the user interface. I'm just making sure that they're set up the same, so the information in the user interface is actually represented to reality, to what the script is set up. Once the user actually messes with this, yes, it'll change the scale. But if you have say I default to 2, And I will have to go through this sprint, and I'm going to put labels on all these so that we can actually see, instead of just a visual representation of where the scale is, it'll show like, oh, you're at a size 2 or something. But how come my size is all the way up? I'm expecting a really big size, and it's painting that, right? So the UI by default is mismatched from what the current default values are in your script. Just be aware that there's kind of two values. When you first create your UI, you kind of have to, a little bit later when you get slick, you might have your UI read in the value from your script, and you don't have to worry about this. But for now, you're just making sure they're all set together, all right? But the first time I use my user interface, there might be like a weird pop value or something because the UI wasn't connected to what your actual default value is. But then you use your UI for the first time. Now the UI is driving your values, so it's all one-to-one. It's all related. But know that I wanted to start at a 0.5, so I set my UI to same, just as a complement to the user to make sure that the information is good for them. I'm going to skip this. So this just reads in the click position and spawns it. You can morph it, mess around with it, put some randomization into it. This one by default was 0 to 1. All I'm going to say about this is that some people didn't want pure blacks and pure whites in their color range. So when you get RGB of all 0, you're going to get black. RGB all 1, you're going to get white. So if you don't want that, you can mess around with your min and max. These are your min and maxes. You can change them. So if I do a min of 0.2, now I will not get those pure blacks. But I have to update my sliders with this, right? Because now my script says, I'm giving you a range of 0.2 to 1, but all the user has to do is pull those sliders down to 0, and they've just overwritten that. They're now back to 0. So I got to make sure my min matches again, 0.2. Now, if I wanted to change the max from 1 to 0.8, I'm in a little bit of a different situation because the number's not hard-coded right there. So if I go up, here it is. They're all defaulting at 0.1. So I just have to go in there, change those, save my script, let it compile. So now my script is defaulting to 0.8 at a range of 0.2 to 0.8. So I just have to update all those numbers. Now my sliders represent what I wish, and it's connected to the scope in my script, my variables in my script. So if you paint, you might notice that you just were not getting any chance of whites or blacks. But as I pull these down, you might remember that if, like, say we're just painting one color, say blue, you would get a range from black to pure blue. Now we're just getting like a deep, deep blue to a regular blue. And if I pull them all down, instead of black, we get this like dark gray. But you can play with these numbers as you wish. These are min and maxes that are available to you. All right. I'm going to keep going. So we were just talking about parents in relation to prefabs and the user interface. Well, we actually have 3 different ways that we can delete stuff now. One's timer based, which happens to be here. You don't really have to do much about that. It kind of keeps track of itself and knows when it destroys itself with using this function. Kind of stuff's abstracted from us. We don't have to worry about it. We have this feature up here, which is mapped to our left click. It's just reading in if we're hitting colliders. We don't need to connect that. And we can turn this feature on and off with the user interface element. But right now it's just input. There's no user interface element to it. Our third way to delete is we want to delete everything that currently exists that we've drawn. on the scene. So this is, we have to think a little bit how we're going to gather this information, because by default, we're just like spawning objects right at the root of our hierarchy. They're just kind of filling up the hierarchy. We have no easy way to go find everything when we want to delete it. So what we can do is we're spawning these primitives. We can set their parent to this manager game object, this click detector, input manager, whatever you called it. We could throw them all underneath that, and so that it's easy to find them, we want to delete them all. So to do that, we say this is the primitive that we created. It's a game object. The way that parenting is handled in Unity, it's all through the transform node. It's all through the transform component. So we have to say, okay, this is the game object. Go find its transform, which since we do that a lot, we can use a shorthand .transform. Just know it behind the scenes, it's saying get component. Which component are you looking for? We're looking for the transform. Remember that method call, and it had the side brackets and stuff. Now within the transform is aware what the parent is. This is not set by us explicitly. It's either, I don't know what it comes out to, like null or root, and it just puts it at the top of the hierarchy. We are setting it explicitly this time. So remember, parents are transformed. So we have to say this, the instance of this script that's running, which we can have multiple instances of one script running if there's multiple game objects spawn that have this script. But in this case, we have one game manager that's in charge of clicking our user input. This script is connected to just that game object, so just one instance is running. We say this.transform. So the click detector has the script on it. The script is a component. It lives on the game object. This is referencing this component, this script, or this instance of a script. It's saying go find its transform, which is shorthand for saying go up to the game object, use the get component method call to find the transform. Once we're at the transform, we know that that's what the parent should be of the primitive that we're spawning. So if I click play, notice as I close up click detector, there's a little arrow and it goes away. If I open it up, here's all the spheres that we're spawning. And if I switch it over to another prefab, or in my case, another Unity primitive, that's the name of it. I don't care what the name or object, whatever they are, they're just all underneath the click detector. Now it's going to be super easy for me to find them and delete them to create the delete method. So here's this function. It's public. I'm going to expose it to my user interface. It's just called destroy objects. Within it is a for each iterator statement. So this week, this guy who does this create this clock, he goes through while loops, and then he does a nice way of introducing, oh, we really need this while loop for this reason. Oh, for some reason we need an iterator, so we have a while loop with an iterator, an integer that we keep iterating to keep track of what's happening. Then he's like, well, we're just one step away from just using a for loop. And so anyway, he goes through these structures. I'll go through with the videos. You'll learn about while loops and for loops. But for now, we have this for each. It's shorthand. It hides a lot of what's happening behind the scenes. All know that for each element in a list of elements, do something. So for each transform that's in a list of transforms, which are all the children underneath this game object. So for each in this transform, all of its children transforms, destroy the child. So the child is, in this case, a name for a transform that is underneath the transform of our click detector. So if we were just say destroy child, we're just destroying the transforms, not the entire game objects of our paint strokes. So we say destroy child.gameObject. Go up from the transform, the whole game object, the whole paint stroke, destroy that. go through all of our children and destroy their game objects. So it's nice shorthand, easy functionality to use for now. And later on this week, we're going to learn about while loops and for loops. So basically, we're creating a list of all the children transforms. We're iterating through them all. And we will build this out into like a larger for statement later. So every time we create something, we parent it to this manager. And now we created this nice public method to go through and destroy them all when we care to. So for this, I'm going to create under canvas, we have the button destroy all. I called it clear. The button is the most simplest UI interactive. So on click, empty rounded parentheses. It's not going to pass bools, ints, floats, nothing else. It just says if you click this button, it's going to execute some function. What function do you want to execute? Well, I want you to go to click detector and I want you to call the destroy objects method. So when I click this button, it finds everything that's underneath that click detector and deletes it. It's just calling that destroy objects method here. Sound good? All right, so this by default was, or last week I should say, was just this destroy method with a number, a time delay of when to destroy. I just wrapped it in an if statement. That if statement is testing this private bool called time destroy is on. By default, I set it on. I set it to true. So this if statement always executes to true, and we always destroy the object after 3 seconds. So to expose that to the user, I created this toggle, called it toggle time destroy. It's this one here. By default, I left it on. If you wish to have this feature be turned off by default, you would turn off your UI element, and you would set this bool to false, and then let the user turn it on if they care to. But by default, it's on. And my user interface element, it shows that it's turned on. And then what this passes is when the user interacts with it, it sends out a bool, true or false, a 0 or a 1. If it was on, if the click was on, the check was on, and you click it, it turns it off, it sends a false. If the check was off and you click it and it draws the check, and it sends out a true. So what am I connecting it to? This method here. Public method reads in a bool, sets our own bool to that. So whether you want to run this line of code or not, we put it in an if statement, check this bool, and we destroy if it's true and not if it's false. So that is all of the features up into this new feature. So I turned off time destroy, and stuff is not being destroyed. I can left click on it, or click clear. All right, is there any questions? Let's turn that off. All right, when's this class over? 3:50. All right, this class is even less time. I'm gonna be running over. You can leave if you care to, just be quiet. It'll probably take me an extra 10 minutes. I'll be done by 5. Oops, not that. All right, so how do we initiate this figuring out where the last time we drew something so that we don't have to have these big gaps in our paint stroke if the user moves the mouse really fast? So first off, we have to somehow remember the last place that we clicked. So I'm going to create this private vector 3. I call it last click position, and I just set it equal to a 0 vector 3, which is 0, 0, 0. So the reason I do this, first off, it's unlikely that the user input would ever feed a 0, 0, 0 in. First off, the user would have to have the mouse at x equals 0 and y equals 0, which is very unlikely. And to top that off, whenever there's user input, we put this distance float, this float called distance, we put it into the z value for this vector 3. So usually we're drawing stuff out like 5 units, 6 units, 7 units out from the camera. A distance of 0 would mean we're drawing right on top of the camera. You would never see it. So a vector 3 of 0, 0, 0 would mean the user would have to have the mouse at x equals 0, y equals 0 on the screen. And we would have to be setting the distance value to 0, which is really unlikely that this would happen. So this is why I'm using this value. And I use checks for it later, but this gets at the end. So let me cancel that out. And let's go down here, turn off what we normally are using for scale. And I do a check. If the last click position is vector 3, 0, then we just do what we're used to doing. We randomly do scaling between 0.1 and 1. And I showed you that you can multiply it by size if you want to open it up to the user to mess around with the slider. So the first object that we're dropping down, since it has no previous reference point, it's not like the user clicked. We don't have another reference, another previous sphere or paint object that we drop down. So that first one that we drop down, when the user first clicks, right click, just give it some random scaling that we already have figured out the feature for. Else, we're going to get in there and we're going to do some math and figure out where the last point was and how to morph our current paint blob. So that must be from last class. So let's just deal with float x for the x position. All I'm doing is figuring out some float for the x, y, and z, putting it in a vector, adding that, making our scale that. That's at the end of the day what's happening. So let's just look at the x value for right now. You know, before I do that, let me go back here and kind of show you my thought process of how to figure this out. So I'm going to turn off time destroy. I'm just going to draw and just try and move really quickly. So notice that when I move the mouse really fast, there are these large gaps in my paint stroke. And this happens in both left, right, up, and down. And if I'm moving at an angle, it's both. So I have to figure out, both on the X and the Y, where the last paint stroke was to then figure out the scale for the one I'm currently drawing. So I can say that this gap's really big, but I kind of want to, so for example, this stroke that I dropped here, here's the previous one. I kind of want to know the distance between them, and I kind of want to scale them up to that for both X and Y. So let's just deal with X for right now. So float X. Right now I'm just going to take this section. I'm interested in the last click position and subtract, our position from that. So that was the first step that I took in my thinking process for how to do this. So let the script compile, and this is what it's looking like on X. Turn off time destroy. So, first off, I get this really large paint blob as my first stroke. That's something I'll put that aside. I gotta figure that out. Secondly, it seems to be working pretty well. But if I click on one of these, press the F key. Oh, I just happened to click on one. That the scale is 0. It's flattened out and it's black. It doesn't look good. So this is bad. I'm getting scales of 0. I got to figure that out. And if I click on another one, here, this one I'm getting a negative value. While it looks fine in the game view, I can't confirm if that's going to render right on WebGL or whatever I'm building towards. So this might come out black or it might be invisible or something. So I don't want negatives and I don't want 0 scale. But I'm kind of liking it. It's kind of correct. So first off, negatives. So I'm going to use a method from this math class. So mathf is a library from Unity. It deals with math functions for floats, for decimals. So mathf. There's tons of methods in there. You can look at the scripting API, like list out a bunch of functions and what input they need and what they do. In this case, I'm going to use absolute. Returns the absolute value. So I'm saying, okay, whatever my last position is, subtract my current position. I just want to know this distance, but I always want it to be positive. I could do this in code, by the way. I could say if the result of this is less than 0, then negate it, give me the positive, else just return what I have because that would mean it's positive. So just know that this is a relatively simple piece of code that you could write yourself in this if-else statement, but somebody already did it for you. Somebody thought of all the optimization and all the tricks around absolute values. Don't have to worry about it. You can just use this math method. So now I got rid of my negative scales, but I have to deal with the fact I got 0 scales. So I'm just going to wrap this answer in a method called clamp. Clamp reads in 3 values, the value that you want to check, the min, and the max. So up on the board, if I call clamp with values 11, 1, and 10, meaning my value that I want to check is 11, my min is 1, my max is 10, what's clamp method going to return back to me? Something in a name. It's clamping. What do you think it's going to do? What do you think it's going to turn back to you?
If the number is lower than the minimum, then it will return the minimum. And if the number is higher than the maximum, it will return the maximum.
So what would 11, 1, 10? Value 11 with a range of 1 to 10. What's it going to give you?
If you put 11, it will return 10.
Yep. That's right. And your definition is correct. So if we do -3, 1, 10. A value of -3 with a range of 1 to 10. 1. Yes. It's going to return the closest value within the range. It is outside the range. If I give you 6, 1, 10, value of 6 in a range of 1 to 10. Huh? 6. So if the value is within the range, it will return the value. If it's outside the range, it's going to get whatever side of the range it's on. It's going to clamp it within the range. So I got rid of my negative issue. Now I'm looking to get rid of my 0 issue. So whatever this value is, I'm going to clamp it between 0.1 and 5. I'll get into why I picked 5 in a minute. but at least we're clamping down. And I'm just doing the same process. When I'm picking these numbers out, I'm either manipulating the code, clicking play, seeing what happens, or exposing them into the inspector and messing around with the numbers. And you do the same thing. You're basically user testing for yourself, and then you expose that more to the user once you've kind of safety proofed it. So I'm clamping it between 0.1 and 5. So it's looking pretty good. And I click on some of these values. They're nice range, not negative. I don't see any black flat things. We're good, right? So now I wanted to introduce, the issue I had with this was it's looking good. It's filling in the paint strokes. Maybe it feels more like a painting program. And we do have one issue there we'll figure out. But they're kind of very similar. So I wanted to introduce some randomness. So this is why I did this random range here. So we figure out the distance, we absolute it, we multiply it by this random number pulled from this range, and then we clamp it down to make sure it's in some safety guideline. It doesn't look crazy. It's not like so small you don't see it, so big it like takes up the whole view. So what numbers did I want for the random range? Well, the min, I said, okay, I did 0.5, like, okay, half it. Like whatever it ends up being, make it half as big. That's interesting size to me. And then I said, okay, I'm doing 5 units. So let me show you where I came up with 5. So if I make a sphere, I probably should just reuse the other one. But if I open up the scale on it, 5, we're getting to about a third of the screen real estate. 10's getting pretty big, but it's manageable. And about 15 is my whole space. So it's like, I kind of like 5 as like my max paint stroke. And I can give it variability up to, say, 15. So these are kind of my limitations that I'm dealing with based on my screen real estate. So this is what I'm clamping down. So I multiply this by 3. So this randomness can sometimes, a small percentage of our randomness can actually multiply it by 3. And I'm clamping it, whatever the value comes to is 5. So it feels, now I'm getting a randomness between not only 1 to 3, but actually half a unit to 3. So 6 times in my variability, but I'm clamping it down to something that's like a third of my screen size. That makes sense for a paint stroke. So anyway, you would expose your numbers out into the inspector, mess around with them as you click and play, make note of what's really interesting. You would set these or expose them to the user. But that's how I got these numbers. That's how I got this nested math equation. And then I do the same for x and y, except y is just checking on the differences in y. So let me save that. And then before I figure out what I want z to be, let me put it back to something that you're used to. Random between 0.1 and 1. So that we've dealt with over and over again. So x and y, I kind of figured out what I want, but I haven't figured out what I should do with z, or the depth of these strokes. So as I paint it, this is what happens. This looks really good. Notice as they're slow movements, I'm getting like a whole bunch. And as I move a lot, they're kind of spaced out. The problem I have with this is like they all pretty much more or less are the same depth. So even when they're like really narrow, you get like this cigar shape, and it just it doesn't look good to me. So I'm like, what would make sense for the z aspect, the depth aspect? And for me anyway, you'll figure out something else. I said, well, x is going to be some random information. between some ranges that I've clamped down to based on how the user's moving the mouse. Same with Y. I'll never know what X and Y are. I know what their min and max is going to be. So why don't I just take the average then? So I added them up, divided by 2. Whatever they are, one might be really big, one might be really small, both might be really big, both might be really small. Let me just take the average of them and see what that looks like to me. And so I get something like this, where when they're really small, their depth is proportional to it. When they get really big, they kind of bloat out. So I like that. There's a nice correlation, and there's nice distribution of these sizes. So that's how I got to this. But you saw that I just kind of figured a few things I wanted to try to approach, and I found something that worked for me, and you can completely do something even if you're staying with this structure of what I'm doing, morphing paint strokes based on distance from the last one, you can just come up with something completely different than me. And so lastly, I'm putting this all into the local scale. And then the only thing I have to deal with at this point is that the first stroke is wild. I don't want to click right away because there's no previous information. It just does a random sampling 0.1 to 1. But say I move down here. Look how big that gets. So as you continue painting, it's fine. It's that first stroke is wild. Now what's happening is, say I'm painting, and my stroke was up here, and I manipulated this, and I'm way over here, and I click again. My last paint stroke was on that other line of information, way off from where I am now. So it's saying, oh, your last position was way over there, you're way over here. It's going to make this huge scaled object. So this is great. This reads in, well, if we have a last click position of 0, which is the first stroke of the entire, when the app first runs. There's no previous information. It'll just make a little random stroke. I want something like that. So I check when the user releases their finger from the right mouse button, they must be ending a stroke. So get mouse button up on 1 or right mouse button. They must have just finished painting. If they did, we're going to reset the last click position to 0, 0, 0, so that when we get down here, for that first time we lay down a stroke, it'll just do this. It'll just set it to a nice little range. It won't do this measurement distance from the last stroke. And now everything feels good. All right. Change the size. Cool. Actually, I think the size isn't computing anymore. So I think I've overwritten this. So I got to update my user interface. I think it's only adjusting that first stroke of your line is the only thing it's actually interacting with at this point. Cool. So I am done. Just know that I am going to assign you this clock tutorial. It's pretty lengthy. It's great. I'm going to go through it. Eventually, I'm going to tie the clock into my world, into my paint stroke, and change lighting. You don't have to do that. You can start to do what you want as long as you're getting like 5 distinct features, each with their own user flow and this whole like project description. You're good to go for each project drop. So I've already came over a few new features for project 2. I'll get up like the videos. I'll get up, hey, be aware that for sprint 2, which is due here, end of the spring, I want you to have 5 features. These are what the user flows look like. This is what a WebGL build, which you're very familiar with now. And this is what mine looks like. This is my demo. And then I'll put up my example posting. And we'll move from there. All right.